Okay, I'll start with, I think Abhishek and Subiksha are there. Okay. Can you able to hear my voice?
Yes, ma'am.
Subiksha, another one person is there. Left. Okay, ma'am. I'll proceed with it. So here today we are going to discuss about the communication system. In communication system, we are going to discuss about the amplitude modulated systems. Okay. So myself, Dr. Tilagam, ASP from ECE Department. So I'll be handling this amplitude modulated system topic. Okay. So here no, it's showing recording for you, Abhishek.
Yes, ma'am.
It's showing
Record.
recording. Okay, okay.
Um,
Okay, so in amplitude system, amplitude modulated system, so we are here, if you take analog modulated system, we have AM, FM and PM. So in that we'll be here we are going to discuss in deep about the amplitude modulated systems. So here, what about the what actually what do you mean by communication system and what do you mean by communication process is that? So if I want the process of establishing a communication between the 2 points, and it is nothing but information exchange between the 2 points. So now, how about the signal is the audio signal? It ranges from 30 hertz to 20 kilohertz. Will be the range of frequencies we'll be using for transmitting the signal. And another term is you are familiar about the modulation. So here I'm going to discuss, just give an overview and we'll solve some gate problems. Okay, I'm not going to touch in deep with the topics. So I'll just give an overview of what are all the things so that if we can solve problems related to the amplitude modulated system for gate exams. Okay, so in modulation we have a continuous modulation scheme. So in which the carrier is continuous. Examples are amplitude and angle modulation. And in pulse modulation, so next one is we have a pulse modulation type. So in pulse modulation, it is there we have analog and digital. So in analog, we have pulse amplitude modulation, pulse width, and pulse position. Okay, and similarly in pulse digital, we have PCM pulse code modulation, delta modulation, and differential pulse code modulation. Okay, and next one is digital modulation scheme. So it is used for data transmission, and the types are ASK, FSK, and PSK. So these are all the types. And what is the need for modulation is, so the need for modulation is in order to go for multiplexing. So if when I'm multiplexing the signal, obviously we'll get interference. So to avoid that interference, we'll be going for modulation. So because this modulation will be done at the with the help of higher frequency. So if I'm doing at the higher frequency, that is in different level, we can reduce the interference. And one more thing is the size of the antenna. Okay, so if for low frequency, since frequency and lambda are inversely related, so as far as how much I am minimizing the frequency, it depends on the wavelength also. Okay, so if I go for higher frequency, the antenna size will be minimum. Okay, so if I'm having, for example, if you look at this one. So here size of the antenna, in the size of the antenna it is 30 hertz, but the length is 2500 kilometers. Okay, because that is the antenna size is calculated by lambda by 4. So if this is the case, the antenna size will be 2500 kilometer, so which is an impractical thing. So if I go for 1 megahertz carrier, 1 megahertz carrier, and it is the antenna size will be of lambda by 4, which is 75 meter. That is also big. So if I go for 100 megahertz carrier, the carrier frequency is very higher. The antenna length will be very smaller, so that which will be practically applicable. So for that purpose also we are going for modulation, and also for narrow banding the signal we use the modulation. Okay, so this is the main need for modulation. One is for multiplexing, and the other one is to reduce the size of the antenna, and the other one is to narrow down the signal, narrow down the band of frequencies. And next one is, so some of the relations we have in amplitude modulation is that, so here in amplitude modulation, the carrier is changed with respect to the modulated signal. Okay, so with respect to the angle, that is with respect to the amplitude of the carrier, the signal will be modulated, and it is a linear modulated wave, and the carrier wave is expressed as EC is equal to EC into cos omega omega ct. So this is one relation we have. And similarly, modulating signal, we have EM is equal to EM cos omega mt, and modulated signal we have is S of t is equal to EC into 1 plus EM by EC cos omega t into cos omega ct. Okay, so these are all the general relations we have for amplitude modulation. And modulation indexes the maximum modulated signal to the carrier signal voltage. Okay, Vm by Vc or Em by Ec, that gives the modulation index. So these are all the relations which are used to solve the problems. Okay, so the signals is given as Ec. So this is the center frequency signal, and these are all the sideband signal. Okay, so the carrier frequency signal with an amplitude Ec it is given, and so this omega c minus omega m represents the lower sideband, and omega c plus omega m represents the upper sideband frequency. Okay, so in amplitude modulation we have carrier frequency LSB and USB, that is upper sideband and lower sideband. Hope you are all familiar about this one. And so this all this diagram you will be familiar about it. Okay, so I can rush up this so that I can we'll discuss some problems regarding this one. So this is a normal modulated signal, and this is the carrier wave. So this normal low frequency signal is modulated with the high frequency signal, and it is transmitted as a high frequency signal. And next one is, next important relation we need to know is, so as far as amplitude modulation is concerned, the maximum amplitude is given by the relation minimum amplitude is given by the relation V minimum is equal to EC minus EM, and the maximum amplitude of AM is equal AM, that is V max is equal to EC plus EM. Okay, so the modulation index, it is here it is given as mu. So this mu is given by V max minus V min by V max plus V min. So that is from the waveform generated from the CRO we will be identifying. So when you are giving the input signal and the carrier wave through signal generator, so this will be modulated, and finally we will be getting this signal. Okay, and so here depending on the parameters given, we need to identify what is the modulation index. So if you look at here, the modulation index relation is EM by EC only. Okay, EM by EC, mu is equal to EM by EC. And here, so if the parameter value Vmax and Vmin value is given in the question, we need to use this relation, that is mu is equal to Vmax minus Vmin divided by Vmax plus Vmin. Okay, and next one is power range in the amplitude modulated wave. So in conventional amplitude modulated system, we have a double sideband full carrier. So which means that we'll have LSB, USB, and we also have this carrier. Okay, so carrier will also be there, LSB, USB, and carrier will also be there. So if this is the case, what is the power relation? So the power relation of the amplitude modulated wave is given by carrier power, lower sideband power, and upper sideband power. So this is the relation, and where E is equal to, if it is, we are taking the RMS values, it is given by EC is equals to EC by root 2. So LSB is equals to PVSB, that is vestigial sideband. So usually the vestigial sideband is some 25% greater than the single sideband power value. Okay, so we have discussed about LSB, USB, and full carrier. So what do you mean by VSB is, so VSB represents the vestigial sideband. This is basically used for television broadcasting, and that is 25% greater than the single sideband frequency. Okay, so the lower sideband the value is mu square into EC square by 8R. So this is the relation. So these are all some of the general relation which is used to solve the problem. And so this is a power relation, and so the power relation is also given by PT by PC is equal to 1 plus mu square by 2. That is one relation. And so for double sideband full carrier, for conventional AM, we have 1 plus mu square by 2 into PC, and eta is equal to mu square by 2 plus mu square. So this is the one is the power relation. So this is the power relation, and this one is the efficiency relation. So these are all important. So we can go with the power relation. So just you have to analyze this power relation and efficiency relation. So using this, we'll be solving the problems. So these are all important points. And so here usually the modulation index will be ranging from 0 to 1. Okay, so if it is greater than 1, it is mean that over modulated, and if it is less than 0.5, it is under modulated. So for a normal modulated synchronous modulation, we have to have the value of mu to be 1. So it's ranging from 0 to 1, it should be. Okay, so if that is the case, the efficiency of AM is 33.3 percentage. It is given. Okay, and so if the modulated if the signal is modulated by several tones of frequency, so in n number of frequency it is modulated, then it is generalized as mu t is equal to this relation, root of mu n square by mu n square plus mu 2 square, etc. Okay, that is modulation index. Mu represents the modulation index. So if it is for modulated for several tones of frequency, how the modulation index is related is mu t is equal to root of mu 1 square plus mu 2 square, etc. Okay, and next one is, so in AM itself, we have a different classification. So this one is double sideband suppressed carrier. Okay, so this one is double sideband suppressed carrier. So in the double sideband suppressed carrier, the carrier will be suppressed. So in the earlier case, sidebands will be there and full carrier will be there. So here DSB SC will be suppressing the carrier frequencies. So only two bands will be there. So as far as the system is concerned, 100% efficiency, and this is given by the relation, and upper side bands will be given by these relations. Okay, hope these are all we have studied. I'll rush. I'll go through this. So generally it is used for communication radio broadcasting, and single sideband suppressed carrier. So carrier is also suppressed. One band, one single band is also suppressed. So only we have either LSB or USB. So in that case, how the power relation? So power relation of single sideband is given by mu square by 4 into PC. Okay, so these are all the condition. If you analyze the question and if you find out whether it is a double sideband or single sideband and how the power is related, if you identify that, we can easily solve the problems. So usually this single sideband suppressed carrier will be used for point-to-point communication. So next one is vestigial sideband. So vestigial sideband is an asymmetric sideband systems, and so this in the vestigial sideband, it will be having this vestigial sideband bandwidth is approximately equal to 25% higher than the single sideband. So when you compare the single sideband, so how the vestigial sideband will be is, it will be 25% higher than the single sideband. So this is practically used for television broadcasting and all, which will be having of bandwidth of 6 megahertz, and AM modulator. So these are all the types of modulators we have. Multiplier modulator, usually analog multiplier, non-linear modulator, switched modulators, balanced modulator or ring modulator, SSB generation. Okay, It can be single sideband generation. It can be also used for vestigial sideband. And A and D modulator or deduction, we have two types. One is square law detector and linear diode. So these are all the operation of envelope detector, envelope detector, and choice of time constant. So this is very important. So the choice of time constant is, so the time constant tau. Tau is the which holds the value of RC, that is the resistance and capacitor value. So this will be within the limit of 1 by Fm to 1 by Fc. Fc represents the carrier frequency and Fm is the modulated frequency. So this time constant or this time constant RC value will be within this limit, 1 by Fm to 1 by Fc. So this is one important relation. So we have power relation, efficiency relation, and this time constant relations. Okay, so AM receiver. So this will be, there are two types. One is AM receiver. We have tuned radio frequency receivers, which is cheap and simple, and super heterodyne receiver, which will be mixing the, which follows the principle of heterodyning, that is mixing of signals. So in this we have image signal. So how this image signal is related is, using this we have a problem. So the image frequency FCI is given by FC plus 2FI. So all these things we have studied already. So let me move on with the equation. That is, what is the general equation is, FCI is equals to FC plus 2FI. FC it is a image frequency. So image frequency is equal to carrier frequency plus twice of Fi. Here Fi represents the intermediate frequency. Usually this image frequency, this will be removed at the, we have RF stage and IF stage. So this image signal will be removed in the RF stage only, not in the IF stage. So first stage on the RF stage and next one is the first stage is the RF stage and second stage is the IF stage. Usually this image signal will be eliminated in the RF stage only. Okay, so in the RF stage, in which uh, block this image signal will be eliminated is, the image signal will be usually eliminated at the RF stage itself. That is, with the pre-selector and RF stage, the image signal will be eliminated. If it enters the intermediate frequency, the image signal cannot be eliminated. Okay, so this has to be eliminated within the RF stage itself, image frequency. Okay, so that relation is very important in every all types of this ECE oriented exam. This image signal frequency relation is widely asked. Usually in general, without this relation there will be no question paper at all. So it's a very important question and relation. Okay, and next one is the last slide is, I'll after that I'll go on with the problems. We'll see how the problems are solved. So we'll have some comparison of what is all about the AM system. So in the AM system, what are all the parameters we have is, so we have carrier suppression. The conventional AM is there, double sideband suppressed carrier is there, and a single sideband and vestigial sideband. So in carrier suppression, so that is in conventional there is no carrier suppression. So in DSB fully suppressed, and SSB it is also fully suppressed, and vestigial sideband no carrier is suppressed. Okay, there will be no carrier. And similarly for sideband also. Okay, so these are all the things. And only one sideband is completely suppressed, and one sideband suppressed partially. Okay, so in vestigial sideband, we'll have one full sideband, but the other sideband will be partially suppressed. And what about the bandwidth relation is, here it is twice of FM, and here it is FM, and here it is between FM and twice of FM. The cost and complexity. So for conventional method, it is cost and complexity are very higher, and with the low cost, and here simple, but the receivers are complex. Okay, so because we are suppressing some of the carrier and sideband units, right? So because of that, the cost will be somewhat higher here, other the transmitter part. Okay, and the usages, so conventional AM is used for radio broadcasting and radio, commercial radio, and similarly DSBSA also, and single sideband is used for point to point, and vestigial sideband is for television. So whenever you look at the television application, we will apply only the vestigial sideband system. Okay, so that particular band only used for television. So this is regarding the theory part I want to give for you, and now I'll discuss with the problems. So what are all the things we have discussed? We'll discuss with some of the problems. So these are all some of the gate questions we have. So we'll see how the problems are they've asked. Can you able to see this PDF file?
Yes, ma'am. Yes, ma'am.
Okay, okay. So in amplitude modulation system, so just I'll go on with the question and how they solved. We'll look at it so that you can get some idea. So as we discussed earlier, in the question is in commercial television transmission in India, picture and speech signal are modulated respectively. So for a picture and speech signal transmission, which band is used? That is what they have asked. So for a television application, so for picture, what band of frequency, and for a speech signal, which is preferred. So this is usually, for, as I said earlier, if it is a television application, it is the VSB is preferred. Okay, so but for as we know here, the other options given are, one is VSB, and for speech also it is VSB. Sorry, for picture and speech, both the cases they've given VSB. But for if you take FM specific, we are specific about the noise should be very minimal. For high speech quality, the modulation scheme preferred is FM. Okay, so for in general, for picture we'll be preferring the VSB, and for speech signal, because the FM is highly immune to noise. Okay, so the noise level is, because in AM transmission and all, the noise factor plays a major role here. So the option given is, how about the it is given with the combination of VSB and FM. So we have to choose the VSB and FM. Okay, so for picture we'll be choosing VSB, and for speech they'll be choosing FM. Okay, so the answer is one second. Okay, so for a commercial television application, the chosen is for a picture and a speech signal, VSB and FM only. Why VSB? Is for television application, we'll be choosing the VSB only. But if it is specifically asked for speech signal also, the speech for a speech signal, FM is used. So the option here it is given is VSB and FM. So that is the correct answer. Okay. And next one is, the second question is, in double sideband full carrier AM transmission, if the modulation index is double, then the total sideband power to the carrier power is increased by a factor of dash. Okay, so as is given earlier, some of the relation for a double sideband and the carrier power, we have the total power relation is this one. Okay, so the for AM, the total for double sideband, the total power is given as EC square by 2R. So this relation we have. So using this relation, so this the above relation can also be simplified as this one. So in this, that is the total power is equals to carrier power plus mu square by 2 into PC. PC represents the carrier power. So here this second term represents the sideband power. Okay, sideband power. So I can write this sideband power is equal to so our The second term is the sideband power. So the sideband power can be PSB is equal to mu square by 2 into PC. Okay. So if I rearrange this one, the sideband power by PC is equal to mu square by 2. So here, as I said earlier, the modulation indexes, it is in the range of 1. Or here, what they have said is, if the modulation index is doubled, okay, if the modulation index is doubled, what about the sideband power they have asked? Okay, so that is the, I think that is the question. So what is our question? So our question is, in double sideband full carrier AM transmission, if the modulation index is double, modulation index என்றது என்னது mu value. So if mu is doubled means, what about the total sideband power? அப்ப எனக்கு வந்து mu ஓட relation and sideband relations are there. Okay, so what is the relation I have? So that is PS by so this is the sideband relation and this is the modulation index relation. So modulation index relation எப்படி இருக்கு ஸ்கொயர்ல இருக்கு. இப்போ இத நான் டபுள் sideband வந்து டபுள் பண்ணாக்கா how about the modulation? This will be 4 times. Okay, if I made it twice, it will be 4 times. Okay, so that is why the answer is it will be increased by a factor of 4. So the sideband power and mu are related in a square. It is directly proportional with the square value. So if I increase this by 2, so this will increase by 4. Okay. So the modulation index is increased by 2 means this sideband power will increase by a factor of 4. Okay, so using this relation, they have solved with an answer. And next one is, what is the maximum power? If usually this type of question only will be asked. That is, will be given with the power relation or efficiency relation. So we have to go through it. Power, efficiency, modulation index, image signal. Okay, so these are all some of the, and one more thing is time constant relation. Okay, so using these relation only, usually in AM part they will be focusing on. So we'll look at the maximum power efficiency of AM modulator. So as we discussed earlier itself, AM power efficiency, we will directly know it is 33%. But how this 33% we are getting? So we are having efficiency relation as PS by PC plus PS. Okay, this PS means sideband power divided efficiency. Eta is equals to sideband power divided by carrier power plus sideband power. Okay, so this is equals to, so if I simplify, so the sideband power, we already have this relation. PS வந்து mu square by 2 into PC னு ஒரு relation இருக்கு. So if I substitute this one and I'm taking out the PC value எடுத்துட்டு finally we'll be having this mu square by 2 plus mu square. So this is the general relation. So finally derivation we'll be having this relation. Okay, so here efficiency is related with modulation index by eta is equal to mu square by 2 plus mu square. Okay, so if this is the relation, then how I'll be getting the answer? As we know, the optimum value for mu, that is modulation index optimum value, is 1. Optimum value for AM modulation is considered to be 1. So if I am considering 1 and if I'm substituting in this relation, so 1 by 2 plus 1, so 1 by 3 into 100, so we'll be getting 33% as the answer. Okay, and next one is, my next relation வந்துட்டு consider sinusoidal modulation in an AM system. So assume இதுல என்ன கண்டிஷன் சொல்லியிருக்காங்கன்னா, assume no over modulation. So there is no over modulation. Over modulation என்றது என்னது? So we have modulation concept. Over modulation means the modulation index value will be greater than 1. Okay, and similarly under modulation means the modulation index will be very lesser than 0.5. Okay, so so here the question is, consider the sinusoidal modulation in an AM system. Assume no over modulation. The modulation index is mu and the maximum minimum value of the envelope is given respectively. So maximum value and minimum value வந்து என்ன கொடுத்திருக்காங்கன்னா 3 volts and 1 volts. As we discussed earlier, so we have the relation Emax and Emin. So how modulation index is related with Emax and Emin value, mu is equal to ரெண்டு ரிலேஷன் இருக்கு மாடுலேஷன் இண்டெக்ஸ்க்கு. ஒன்னு வந்து EM by EC. ஓகே, the modulated power, modulated voltage divided by the carrier voltage, அது ஒரு ரிலேஷன். இன்னொரு ரிலேஷன் வந்து என்னன்னா mu is equals to E max minus E min. Okay, so maximum voltage minus minimum voltage. So depending on the question நம்ம வந்து apply பண்ணனும். அப்ப so questionல they have given E max and E minimum value. So what I have to do is I have to use this mu is equal to E max minus E min relation use பண்ணி so the values are directly given. Mu is equal to 3 minus 1 by 3 plus 1, so 2 by 4 is equal to 0.50. So the modulation index is 0.50 will be getting. Okay, I think so what is the value they asked? What is the modulation index value they have asked? So the modulation index value is 0.50. Okay, so this is one part. And next one is which of the following analog modulation scheme requires minimum transmitted power and minimum channel bandwidth? So in the modulation minimum transmit power and channel bandwidth require. So here if you look at the one, finally we had a comparison table, right? So in the comparison table transmitted power and channel bandwidth வந்து எதுக்கு minimum require ஆகும் அப்படினாக்க single sideband is down. Okay, the single sideband will require the minimum bandwidth and minimum transmitted power. So the answer is SSB. Okay, so which analog transmission method will have the minimum bandwidth and minimum power means it is a single sideband. ஏன்னா கன்வென்ஷனல்ல டபுள் சைட் பேண்ட்ஸ் வரும், ஃபுல் கேரியர் வரும். டிஎஸ்பிஎஸ்சில ஃபுல் கேரியர் ரெண்டு சைட் பேண்ட்ஸ் வரும். வெஸ்டிஜியல் சைட் பேண்ட்ல ஒரு சைட் பேண்ட் 20 and then we'll have 25% higher than the bandwidth we'll have. Okay, so requirement will be minimum for SSB. The SSB will be requiring minimum bandwidth and minimum power. Okay, and question number 6. Next question is இதுல வந்துட்டு என்ன சொல்லியிருக்காங்கன்னா suppose the modulating signal m is equal to this one and the carrier signal is x is equal to this one. Which one of the following is a conventional AM without over modulation? So இதுல வந்து எதுக்கு over modulation? In the relationல we have to find out which one is not having the over modulation அப்படின்ட்டு we have to find out. So for this what we need to do is I'll just give an overview because you have studied communication theory and now we have completed the digital modulation, digital communication also. So you have that is a better idea regarding what is all about. So I no need to go in deep about it. I'll say how they are solving this problem. What is the step involved is they have taken the modulated signal. So what are all the parameters they've given us? இது எல்லாமே 1 மார்க். அப்ப நீ வந்து ஸ்பான்டேனியஸா இதை வந்து நீ சால்வ் பண்ற மாதிரி இருக்கணும். கொஞ்சம் கான்செப்ட்லாம் தர வந்தாதான் உனக்கு வந்து அதாவது ஜென்ரல் ஈக்குவேஷன். இப்ப ஏஎம்னா வாட் இஸ் அ ஜென்ரல் ஈக்குவேஷன் அப்படின்றதெல்லாம் உனக்கு தெரிஞ்சாதான் டக்கு டக்குன்னு சால்வ் பண்ண முடியும். ஓகே, ஸோ ஹியர் எம் ஆஃப் டி வந்து 2 cos pi ft fmt into it is given in the question, and similarly carrier signal value is also given. So the conventional method la standard expression enna idukku appdin pathona et is equal to this value. Okay, so this is et is equal to ec into 1 plus mu modulation index value em by ec ninga varum value. Okay, that value into cos omega mt into cos omega ct. Okay, so this is the relation we have. So when the relation, like I'm comparing, one second. Okay, so that is the general relation here they've given us. With the general relation we can find out what is mu value here. So with the mu value we have to find out which is having the convention to over modulation or not. Okay, so if you solve this one, you are taking the general relation. So first equation you have taken, and from this we have found out what is mu value. So mu is equal to 2 here. Okay, so the second parameter term is considered to be the mu value. So that mu value is 2. for option B. So if it is mu is equal to 2, then it is with the over modulation. Okay, and if I take option C, what is the cases? The mu we are getting here is 1 by 2. Okay, so the mu value is, so this value 1 by 4 into 2, here it is given, right? So this value. So what is the mu value is 1 by 2. So which is under modulation. The point, if we are getting 0.5, it is under modulation. So from the relations, if you discuss, so they've asked which is having over modulation. So the over modulation term is this one. Okay, so mu is equal to 2 term. Mu is equal to 2 term. So the option C is correct answer. So here we have option C இருக்கு இல்லையா? Option so this value is the correct answer. So if you are substituting this AC into m of t substitute பண்ணாக்கா, the mu value will be we are getting it as 2. So it is concerned with the over modulation. So the option B. Okay, so the answer is option B. இதுதான் இந்த ஆப்ஷன் பி இருக்கு இல்லையா, எம் ஆஃப் டீன்றதுல இந்த வேல்யூ 2 cos 2 pi t இது சப்ஸ்டியூட் பண்ணோம்னா இப்போ இந்த வேல்யூ வந்து 2. ஸோ இந்த 2 ரெப்ரசென்ட் பண்றது என்னன்னா மியூ வேல்யூ. ஸோ மியூ இஸ் ஈக்குவல் டு 2 வந்ததுன்னா இட் ரெப்ரசென்ட் தட் இட் இஸ் அன் ஓவர் மாடுலேஷன். ஏன் ஓவர் மாடுலேஷன்னா, ஸோ மாடுலேஷன் இண்டெக்ஸ் ஷுட் பி ஆல்வேஸ் வித்தின் த ரேஞ்ச் ஆஃப் 1. Okay, but if you are getting 2, then which means that it is over modulated signal. And so using this relation, we'll be having so many problems. Okay, so if we have we go on with the இன்னொரு ப்ராப்ளம் வந்துட்டு a DSB SC signal is generated using the carrier cos omega ct plus theta. Abhishek, you are getting that recording option.
Yes, ma'am.
Okay. So the envelope of the question is DSB SC signal is generated using carrier cos omega ct plus theta and modulated signal xt. The envelope of DSB SC signal is, they are asking what is the envelope value of double sideband suppressed carrier signal. So how we'll be calculating this one is, so on the carrier signal வந்து இந்த value கொடுத்துட்டாங்க, modulated signal m of t is equal to xt. So these are all the things we have taken from the question. So question, they have given carrier signal as cos omega ct plus theta and modulated signal வந்து xt ன்னு கொடுத்துருக்காங்க. இப்போ டிஎஸ்பி எப்படி நம்ம டிஎஸ்பி எஸ்சி மாடுலேட்டட் சிக்னல் how will be calculating is carrier signal into modulated signal. So c of t into m of t is equal to s of t. இதுதான் வந்து DSB-SC யோட modulated signal value. So I have to take the product of modulated signal and carrier signal. So if I am taking the modulated signal and the carrier signal product, so this is expanded. So we'll be getting x of t into cos of a omega t plus theta. So a plus b formula, if we are expanding means, so if I'm expanding this one, the envelope value will be square root of this one. S of t is given by root of this value. Okay, x of t is given by envelope of the signal is given by root of this DSB modulated signal. So if I'm taking root value for this one, இதுல வந்து இந்த cos square theta இது 1 ன்னு ஆயிடும். So root எடுத்தனா ஃபைனலா x of t தான் வரும். அப்ப the DSB modulated signal value will be x of t. So இதுல இந்த ஆப்ஷன்ல நமக்கு வந்து இங்க கொடுத்துருக்காங்க x of t only positive இதெல்லாம். So அப்ப x of t தான் வந்து அதுக்கு ஆன்சர். And next one is, இது வந்து டைம் கான்ஸ்டன்ட் வச்சு, ஐ திங்க் டைம் கான்ஸ்டன்ட் யூசிங் டைம் கான்ஸ்டன்ட் இல்ல அப்பர் சைட் பேண்ட் லோவர் சைட் பேண்ட், இது வந்து ஒரு சிம்பிள் கான்செப்ட். ஸோ தேர் கிவன் கேரியர் சிக்னல். ஓகே, 1 megahertz கேரியர் சிக்னல் கொடுத்துட்டாங்க. அண்ட் தென் அசிமெட்ரிக் ஸ்கொயர் வேவ் பீரியட். ஸோ டைம் பீரியட் இட் இஸ் கிவன். Okay, so 100 microsecond, and which of the following frequency will not be presented in the modulated signal? So set of frequencies send பண்றோம்னா which are all the frequency will not be present in the that set of frequency அப்படி? That is a question. Okay, so as far as AM is concerned, frequency of the carrier signal வந்து 1 megahertz, that is written as 100 kilohertz, and modulation signal வந்து the time period it is given. So from the time period we can calculate the frequency. So 100 microsecond, so it is converted as 10 kilohertz frequency. Okay, so carrier signal is there and modulated frequency is there. So using this one, what they're saying is, so the modulation is a symmetric square wave. So if it is a symmetric square wave, so the condition is, if it is a symmetric square wave, it will contain only the odd harmonics. Odd harmonic means 10 hertz, 30, 50, 70, 90, like that. That harmonics only it will have. Okay, so if this is the case, how the modulated signal will be? We have FC plus F plus or minus F1. First case la அதுக்கப்புறம் FC plus plus or minus 3 இருக்கும். இந்த மாதிரி அது வந்து distribute ஆகும். So if I'm using this, இதுல வந்து FC it is given as 1000 kilohertz. Okay, carrier frequency. FM என்றது வந்து இங்க calculate பண்ணிருக்கோம் 10 kilohertz. So in the relation la substitute பண்ணா, what are all the frequency we have? 10 kilohertz, 990 kilohertz. இப்போ இந்த ரிலேஷன்ல we have this value and this one. So இப்போ இந்த values எல்லாம் இருக்கு. So which is not present in the signal அப்படின்றப்ப இந்த frequency எல்லாம் கம்பேர் பண்ணி பார்க்கணும். இதுல கம்பேர் பண்ணி பார்த்தா இதுல இல்லாத frequency வந்து எதுன்னா 1020 kilohertz வந்து வராது. ஏன்னா அது ஆட் ஹார்மோனிக்ஸ்ன்றதால ஆட் நம்பர்ல தான் 1, 10, 30, 50, 70 அப்படி தான் ஜென்ரேட் ஆகும். 20 won't be coming. Okay, so that is a relation I want to conclude. I want to discuss, and as we know, we have efficiency relation. So in the efficiency relation, you can calculate that some problems we have seen, and what is the other problem we got to discuss is. The share, I'll share this PDF. If you have any doubt, means you can ask me. Okay, and okay. So finally, I will solve one problem, that is in the time constant வச்சு இன்னொன்னு வந்து image pic. அந்த ரெண்டு problem மட்டும் solve பண்ணிட்டா finish of this one. So here time constant, that problem is an AM signal is detected using an envelope detector. The carrier frequency and modulation signal frequency are 1 megahertz and 2 kilohertz respectively. Okay, so here the given parameters are carrier frequency and modulation FM, the modulated signal frequency are there. What is the appropriate time constant for the envelope detector? So envelope detector oda what is the appropriate value nu kekranga. So the appropriate value ku enna relation already we have is the theory part la the slide la we have this relations. Okay, so the time constant RC value will be between 1 by FC to 1 by FM. இப்போ 1 by FC என்றது என்னது நமக்கு ஆல்ரெடி கொடுத்திருக்காங்க, that is carrier frequency is 1 megahertz, so 1 by 1 into 10 to the power of 6, and the other one is FM modulated signal 1 by 2 into 10 to the power of 3. So அதை simplify பண்ணாக்கா we'll be getting the range. The time constant is between 1 microsecond and 0.5 millisecond. So இதுல வந்து என்ன ரேஞ்ச்ல இருக்கும் அப்படின்னாக்கா option B is the right answer. So it is 1 microsecond. So this is in the range of RI should be satisfied within the range 1 microsecond. An appropriate value for the time constant of the envelope detector is this one. I think option C will be the right answer. Okay, so we are getting between 1 microsecond to 0.5. So 0.2 microseconds will be getting. Okay, there it is between 0.5 milliseconds. So milliseconds la irukku. Appa check panna I think 20 microseconds will be getting. So we check it out that. The thing is, RC
Okay, ma'am.
RC வந்து இப்படி relate ஆயிருக்கும் 1 by FC க்கும் 1 by FM க்கும் relate ஆயிருக்கும். The final problem is last. And this one, so this is very very important problem. Okay, a super heterodyne receiver la AM receiver la one problem, super heterodyne receiver with an intermediate frequency of 455 kilohertz is tuned to a station of operating 1200 kilohertz. The associated image frequency is this one. What is the image frequency they have asked? Okay, so the intermediate IF frequency is IFS 455 kilohertz. அது எப்பயுமே standard AM க்கு. And the next one is it is operating at 1200. That is the signal frequency. Okay, so இதுல இப்ப எப்படி நமக்கு ரிலேட் ஆயிருக்கும் அப்படின்னாக்கா ஆசிலேட்டர் frequency is equal to FS plus FI அப்படின்ட்டு. Okay, FS ன்றது signal frequency, FI ன்றது image frequency. Okay, and how we'll be finding out this image frequency is, so image frequency எப்படி relate ஆயிருக்குன்னா the image frequency is equal to FS plus twice of intermediate frequency. Twice of intermediate frequency. So the intermediate frequency நமக்கு 455 it is given in the question, and signal frequency 1200 it is given. Okay, so if you are substituting this, finally you'll be getting the answer 2110 kilohertz. So that is the image frequency value. Okay, so this is the image frequency value. Okay, okay students, thank you so much. With this we'll finish it off. Ma, 1 second, you remind there. I'll take